Okay, so today we're going to start with chapter 6, and in chapter 6, our focus will be on chemical equations. All right? So, in chemistry, we use chemical equations as a shorthand way of representing what is happening in a chemical reaction. So, it's more convenient for us to use chemical equations because, of course, as you can imagine, writing out a reaction in words will be a bit cumbersome. So the chemical equations is a very shorthand way of describing the equation, and therefore it can be used to summarize the reaction. It can be used to display the substances that are reacting. It can also show what the products of the reaction are. And finally, and this is very important when we get to later topics, it can indicate the amounts of all the substances involved in a reaction. All right, so that's basically what a chemical equation is all about. And therefore, as you're going to see shortly, writing down the correct chemical equation to represent all these facts that I mentioned is very important for us to get as much information about the reaction as possible. So let's talk about what a chemical equation entails, right? Well, in a chemical reaction, as we all should know from now, we have a change where new substances are created from other substances. And when this happens at the microscopic level, what you have are atoms, molecules, and ions basically rearranging themselves, breaking bonds, and connecting with other atoms to form new products. So the substances that are entering the reaction, they are called the reactants, and they are typically written on the left side of the equation. The products are the substances that are formed in the reaction, and they're typically written on the right side of the equation. And as I said before, during a chemical reaction, we have the creation of bonds as a result of bonds being broken. All right? So, as I said before, the chemical equation is a shorthand way of expressing a chemical change, and the equation uses chemical symbols and formulas for the reactants and products that are involved in the chemical reaction. And there are other symbols that you'll see involved. We're going to talk about that in more detail shortly. So, here is an example of a chemical equation. So, on the left, we have the reactants, which are the aluminum and the iron 3 oxide, and on the right, we have the products, iron and aluminum oxide. All right, and as you can see, there's an arrow that separates the reactants and the products, and the arrow basically just gives you the direction of the reaction. The arrow points away from the reactants and towards the products. All right, so this is basically the conventional way of writing down an equation. All right, so as you can see in this equation, there's a reaction taking place as a result of breaking of bonds between the iron 3 oxide and the oxygen. And on the other side, you see that bonds are created between the aluminum ions and the oxide ions. All right, so this is a simple example of an equation representing a chemical change. Now, what you saw just a while ago is an equation, but the equation is not balanced. And what does that mean? Basically, it comes down to showing that the conservation of mass law is obeyed. In other words, the number of atoms created or the number of atoms on one side of the equation must be equal to the number of atoms on the other side. Now, let me just go back to the previous equation. If you look at this carefully, you will see that there are some numbers here, the subscripts, which indicate the number of atoms. And you'll notice that, for example, here you have 2 iron atoms, but here there's only 1. Here you have 1 aluminum atom. Here you have only 2, right? So therefore, obviously, the conservation of mass law is not obeyed based on this equation right here because the number of atoms of each element are not the same on both sides. So in order for us to indicate that or show that that's the case, we need to balance the equation by putting what are known as coefficients. Now the coefficients are placed in front of the formula for the substances, and these coefficients must be whole numbers or integers. And we do that in order to balance the equations to indicate that the number of units, atoms, molecules, moles, or ions of each substance that are reacting. So going back to this reaction here, as I said before, this equation is not balanced because you don't have equal numbers of aluminum, you don't have equal numbers of iron, even though you do have equal numbers of oxygen atoms, right? So what we do is place coefficients, in this case in front of the 2, or I should say 2 in front of the aluminum and a 2 in front of the iron, and that results in the equation being balanced. In other words, the number of atoms of each element are the same on both sides. You have 2 aluminums here, 2 aluminums here, 2 iron atoms here, 2 iron atoms there. All right. In some equations, we see symbols which indicate the conditions that the reactions are conducted under. All right. And those conditions may be placed above or below the arrow. So you might see something like this, a triangle, which basically represents heat. All right. In some cases, you might actually see the actual temperature written above or below the arrow as well. So sometimes you see that. Sometimes you see other conditions, such as if there are any gases, what pressure of the gas that exists, or whether or not a catalyst is added. A catalyst, by the way, is basically a substance that speeds up the rate of the reaction without itself undergoing any change. You may also see some symbols such as what you see here, L, in italics in parentheses. That's called a state symbol, which indicates the state of the substance involved in the reaction. So L is for liquid, and you have some others. S is for solid and G for gas. So for example, we can add those state symbols to this equation to give you the states of the different substances involved in this reaction. All right. So as we said before, in any chemical reaction, we do not have the creation or destruction of any atoms. So therefore, the number of atoms of each element must be the same on both sides. All right. So that is true for any chemical equation that accurately represents a reaction. Okay, so let me just go give you a rundown of the different symbols that are used in chemical reactions. So the plus sign that exists in a chemical equation is typically placed in between the different substances involved on either side of the equation. All right. The arrow basically means yields or produces, and we place that between the reactants and products. We have the state symbol S, which stands for solid, which is placed after the formula of the solid substance involved in the reaction. L is for liquid, again placed after the formula of the substance. G for gas, placed after the formula. AQ, and this is the symbol for substances that are dissolved in water. And we mentioned this before, the triangle, which represents heat, and this is written above or below the arrow. H nu, this is something that is a symbol. It's actually a formula or part of a formula. H is a constant and nu is the frequency of light. And whenever you see H nu, it basically means light energy, and this is written typically above or below the arrow. There is a symbol which is not very often used, at least lately, that I have seen in textbooks, but if you see an arrow pointing up beside a substance, it also means a gas being formed. All right. There's another symbol where the arrow is pointing down, and it means a solid being formed. Okay, so we're going to stop here. The next video will deal with how do we go about writing and balancing equations. Until next time.